This LOS is define a hypothesis, describe the steps of hypothesis testing, and describe and interpret the choice of the null and alternative hypothesis. We're going to start with a bit of an introduction. Statistical inference traditionally consists of two branches: hypothesis testing and estimation. Hypothesis testing addresses the question, is the value of this parameter, say a population mean, equal to some specific value, 0 for example. In this process, we have a hypothesis concerning the value of a parameter, and we may seek to determine whether the evidence from a sample supports or does not support that hypothesis. Estimation seeks to answer the question, what is this parameter value? In estimating, unlike in hypothesis testing, we do not start with a hypothesis about a parameter's value and seek to test it. Rather, we try to make the best use of the information in the sample to form one of several types of estimates of the parameter's value. When we can reduce an idea or assertion to a definite statement about the value of a quantity, such as an underlying or population mean, the idea becomes a statistically testable statement or hypothesis. The analyst may want to explore questions such as the following. Is the underlying mean return on this mutual fund different from the underlying mean return on its benchmark? Did the volatility of returns of this stock change after the stock was added to the stock market index? Are the securities bid-ask spreads related to the number of dealers making a market in the security? Do data from a national bond market support a prediction of an economic theory about the term structure of interest rates? To address these questions, we use the concepts and tools of hypothesis testing. Hypothesis testing is part of statistical inference, the process of making judgments about a larger group, a population, on the basis of a smaller group actually observed, a sample. The concepts and tools of hypothesis testing provide an objective means to gauge whether the available evidence supports the hypothesis. After a statistical test of a hypothesis, we should have a clear idea of the probability that a hypothesis is true or not, although our conclusion always stops short of certainty. Hypothesis testing has been a powerful tool in the advancement of investment knowledge and science. As Robert L. Kahn of the Institute for Social Research has written, the mill of science grinds only when hypothesis and data are in continuous and abrasive contact. Hypothesis testing. The steps in testing a hypothesis are as follows. 1. Stating the hypothesis. 2. Identifying the appropriate test statistic and its probability distribution. 3. Specifying the significance level. 4. Stating the decision rule. 5. Collecting the data and collecting the test statistic. 6. Making the statistical decision. And 7, very important, making the economic or investment decision. Hypothesis testing. The null hypothesis. The null hypothesis is the hypothesis to be tested. Researchers want to reject it. Always includes the equal sign. The alternative hypothesis, what the researcher would like to conclude, supported if the researcher rejects the null hypothesis. We can formulate the null and alternative hypothesis in 3 different ways. Number 1, the hypothesis equals 0 versus the alternative that it does not equal 0. Okay, that's a not equal to alternative hypothesis. The hypothesis is less than or equal to 0 versus the alternative hypothesis greater than 0. That's a greater than alternative hypothesis. And finally, the hypothesis that is greater or equal to 0 versus the hypothesis that it's less than 0. So you can see in the null hypothesis, it always includes the equal sign. Equals, less than or equal, greater than or equal. And it's the alternative hypothesis that is not equal, that is a greater than alternative hypothesis, or a less than alternative hypothesis. Just a quick preview towards where we're headed. We're going to be looking at different tests and calculating different test statistics and then comparing them to our hypothesis and alternative hypothesis. So the first test is a test concerning a single mean. So we identify the appropriate test statistic and interpret the results for a hypothesis test concerning the population mean of both large and small samples when the population is normally or approximately distributed and the variances is 1 known or 2 unknown. So we calculate the test statistic and then we compare. The second is tests concerning differences between means. We identify the appropriate test statistic and interpret the results for a hypothesis test concerning the equality of the population means of 2 at least approximately normally distributed populations based on independent random samples with 1 equal or 2 unequal assumed variances. And I won't go through all the calculations and formulas right now. We'll be seeing that later. We'll also be looking at tests concerning mean differences, where we identify the appropriate test statistic and interpret the results for a hypothesis test concerning the mean difference of 2 normally distributed populations. Finally, we're going to look at identifying the appropriate test statistic and interpret the results for a hypothesis test concerning 1, the variance of a normally distributed population, and 2, the equality of the variances of 2 normally distributed populations based on 2 independent random samples. So that's the final test. They're concerning variances. So there's a test concerning a single variance and tests concerning the equality or inequality of 2 variances. And that's the last slide for this LOS. Thank you.